Here is the most unsettling truth about our place in the cosmos. We are invisible. Not invisible like a needle in a haystack. Not invisible like a single fish in the ocean. Invisible in a way that makes those comparisons laughably inadequate. We are so invisible that even civilizations searching for us with technology beyond our imagination would never find us. This is not about whether aliens exist. They probably do. The mathematics of the universe almost demands it. Billions of galaxies. Each galaxy containing billions of stars. Each star potentially hosting planets. The odds of Earth being the only world with intelligent life are essentially zero. So where is everyone? The answer is not that they are hiding. The answer is not that they have not looked. The answer is that finding us is physically impossible. Brian Cox has spent decades wrestling with this question. He has gazed through the most powerful telescopes ever built. He has analyzed data from instruments that can detect individual atoms across light years, and he has reached a conclusion that most people do not want to hear. The universe is not just big. The universe is structured in a way that makes detection between civilizations nearly impossible. We are alone not because no one else exists, but because no one will ever know we are here. This realization changes everything we thought we knew about our place in the cosmos. For decades, we have assumed that if intelligent life exists elsewhere, contact would eventually happen. We assumed that advanced civilizations would have the capability to find us. We assumed that our signals were reaching out, announcing our presence, inviting response. But these assumptions were built on hope, not physics. They were stories we told ourselves because the alternative was too lonely to contemplate. The physics tells a different story. The physics tells us that detection is not just difficult, it is functionally impossible. Let me show you why. Let me walk you through the physics of detection. Let me demonstrate why our signals, our signatures, our very existence remains hidden from any civilization that might be searching for us. Because once you understand the numbers, once you grasp the scale of what detection requires, you will realize something devastating. We could be surrounded by intelligent life, thousands of civilizations, millions of civilizations, and none of them would ever know we exist. The first barrier is the weakness of our signals. We often imagine that our radio transmissions are streaming out into space, announcing our presence to the cosmos. Television broadcasts, radar signals, cellular communications, all of it expanding outward at the speed of light, forming an ever-growing bubble of detectability around Earth. This is technically true. It is also profoundly misleading. Radio waves obey the inverse square law. As they travel outward, they spread across an ever-increasing sphere of space. The energy that started concentrated becomes dispersed, diluted, weakened. A signal that is powerful at its source becomes a whisper at 1 light year and essentially nothing at 10 light years. By the time our strongest transmissions reach the nearest stars, they have become so faint that distinguishing them from the background noise of the universe requires technology that might not be possible. Let me put numbers on this. The most powerful radio signal humans have ever intentionally sent into space was the Arecibo message in 1974. It was directed at a globular cluster about 25,000 light-years away. The transmission lasted just 3 minutes at a power of about 1 million watts. That sounds impressive until you do the math. By the time that signal reaches its target, the power density will have dropped by a factor of approximately 10 to the 28th power. 10 to the 28th power. Let me help you understand that number. If you took all the energy humans have ever produced in all of history, every fire ever burned, every engine ever run, every power plant ever operated, all of it combined would still be insufficient to make that signal detectable at its destination without a receiving antenna larger than most planets. Brian Cox has explained this with characteristic clarity. Our radio signals are not beacons. They are not lighthouses piercing the cosmic darkness. They are candles. Candles being observed from the other side of the galaxy while standing next to the sun. The background noise of the universe, the cosmic microwave background, the radio emissions from stars and galaxies and pulsars, all of it drowns out our signals completely. And here is what makes this worse. Our signals are not even designed to be found. Television broadcasts are meant for antennas on Earth. They beam outward in specific directions. They carry information encoded in ways that would appear random to anyone who did not already know what they were looking for. An alien civilization intercepting our television signals would receive a burst of apparent noise lasting microseconds. They would have no way to know it was artificial. They would have no way to distinguish it from natural phenomena. They would not even know to look for it. Our communications are accidentally leaking into space, not deliberately transmitted. And accidental leakage is not how you make yourself known to the universe. The window of our detectability is also remarkably short. Humanity has been producing powerful radio signals for about 120 years. Before that, we were invisible, and we are becoming invisible again. Fiber optic cables are replacing broadcast transmissions. Directed communications are replacing omnidirectional broadcasts. The brief era of Earth as a radio source is already ending. Think about what this means in cosmic terms. For billions of years, Earth was silent. Then, for about a century, we produced detectable radio emissions. Now those emissions are declining. The window of detectability might be only 200 years. Perhaps 300 if we are generous. 200 years out of 4.5 billion. That is the window. That is how long Earth will have been a radio source in all of its existence. A civilization searching for us would need to be pointed at our exact location, at the exact right frequency, during the exact century when we happen to be leaking detectable signals. The odds of that alignment are astronomically small. We are not a beacon. We are a brief flicker that most of the universe will never notice. Brian Cox has made an important point about this temporal window. We often imagine alien civilizations searching for us across millions of years, but the Earth has only been producing detectable signals for a century. The overwhelming majority of Earth's history has been radio silent, and the overwhelming majority of its future will be radio silent as well. We are living in the one brief moment when our planet can be heard. And even now, we can barely be heard at all. But what about deliberate attempts to make ourselves known? What about SETI in reverse? What about actively broadcasting our presence? This is called METI, Messaging Extraterrestrial Intelligence, and it faces the same fundamental problem. Distance and signal degradation do not care about your intentions. A deliberate message fades just as quickly as an accidental one. To send a message that could actually be detected at interstellar distances, you would need power levels that we cannot achieve. You would need to broadcast continuously for centuries to have any chance of being noticed. You would need to know where to aim, which stars to target, which frequencies to use, and you would be sending a message to civilizations that existed thousands of years ago, hoping they would still be listening when your signal arrived. Brian Cox has reflected on this deeply. The physics of electromagnetic radiation creates a kind of prison, not a prison of walls and bars, but a prison of weakness and distance. We can transmit, we can broadcast, we can shout into the void, but the void is too vast, and our voices are too small. The universe has ensured that radio communication between civilizations separated by interstellar distances is essentially impossible. Let me introduce the second barrier, the problem of knowing where to look. The galaxy contains somewhere between 100 billion and 400 billion stars. Our sun is one of those stars. Earth is one planet among trillions. If an alien civilization wanted to detect us, they would first need to identify our star as worth examining. They would need to point their instruments at our specific location among the vast stellar wilderness. The odds of randomly selecting our sun are essentially 0-1 in hundreds of billions. And even if they happen to look at our sun, they would then need to detect Earth itself. A rocky planet smaller than many moons, orbiting at 1 astronomical unit from a star that outshines it by a factor of billions. Let me put some numbers on this to help you grasp the challenge. The Sun is about 1.4 million kilometers in diameter. Earth is about 12,700 kilometers in diameter. The ratio is roughly 109 to 1, but the brightness ratio is far more extreme. The Sun puts out about 3.8 times 10 to the 26th watts of power. Earth reflects only about 1.7 times 10 to the 17 watts. That means the Sun is roughly 2 billion times brighter than Earth as seen from a distance. Detecting Earth next to the Sun is like trying to see a firefly next to a lighthouse. Not just any lighthouse. A lighthouse 2 billion times brighter than the firefly, separated from it by a distance that makes the firefly appear as a single pixel. We have only recently developed the technology to detect exoplanets at all. And our detection methods are indirect. We cannot see the planets themselves. We infer their existence from the tiny wobbles they cause in their parent stars, or from the minuscule dimming that occurs when they pass in front of their suns. These methods work only for specific orbital configurations. Many planets remain completely undetectable. An alien civilization with advanced technology might be better at planet detection than we are. But the fundamental challenges remain. The planets are small, the stars are bright, the distances are enormous. Detecting Earth from across the galaxy would require instruments of staggering precision, pointed in exactly the right direction, operating for extended periods. Brian Cox has made an important observation about this. We assume aliens would be looking for planets like Earth. We assume they would know what to look for. But why would they? Their own planet might be nothing like ours. Their biology might be completely different. The signatures we consider obvious signs of life might be meaningless to them. We look for oxygen in atmospheres because oxygen is a byproduct of our kind of life. We look for liquid water because our biology requires it. But alien life might not need oxygen. Alien life might not need water. The chemical signatures we consider biosignatures might be invisible to civilizations with different biological foundations. This creates a fundamental problem of recognition. Even if aliens detected Earth, even if they analyzed our atmosphere, they might not recognize it as harboring life. Their definition of life might be so different from ours that we would not register as alive to them. We might be invisible not because we are hidden, but because we are unrecognizable. The third barrier is the problem of time. This is perhaps the most devastating barrier of all, because it compounds every other difficulty. The universe is not static. It exists in time as well as space, and the vast expanses of time create synchronization problems that might be insurmountable. Let me help you understand the timescales we are dealing with. The universe is about 14 billion years old. Our galaxy is about 13 billion years old. Stars have been forming and dying for almost that entire span. The universe has had billions of years to produce civilizations. Where are they all? The answer is that they are scattered across time as well as space. Just as civilizations are separated by thousands of light years, they are separated by thousands, millions, or billions of years. Two civilizations that both exist somewhere in the galaxy might never overlap in time. They might miss each other by geological ages. Earth has existed for about 4.5 billion years. Life appeared about 4 billion years ago. But intelligent life, technological civilization capable of producing detectable signals, has existed for barely a century, 100 years out of 4.5 billion. That is 0.00002% of Earth's existence. If an alien civilization looked at Earth at any random point in its history, the overwhelming probability is that they would see a planet without detectable technology. No radio signals, no city lights, no atmospheric pollutants indicating industry, just another rocky planet orbiting a yellow star. They would have no reason to look more closely. And the same applies in reverse. Any alien civilization capable of searching for us has existed for some period of time. Maybe they have been around for 1 million years. Maybe they have been around for 10 million years. Maybe they are no longer around at all. The window during which both civilizations exist, both possess the technology to detect each other, and both happen to be looking in the right direction is vanishingly small. Brian Cox has called this the synchronicity problem. Two civilizations need to exist at the same time in the same region of space, both with technology capable of interstellar detection, both actively searching, both lucky enough to look in the right direction at the right moment. The probability of this alignment is essentially zero. Let me make this concrete with numbers. Imagine the galaxy contains 1,000 technological civilizations at any given time. This is probably optimistic, but let us grant it. Each civilization exists for perhaps 100,000 years before going extinct or evolving beyond detectability. The galaxy is 13 billion years old. 100,000 years divided by 13 billion years is about 1 in 130,000. At any given moment, about 7 or 8 civilizations might exist simultaneously. 7 or 8 civilizations scattered across 100,000 light-years of galactic space. The average distance between them would be tens of thousands of light-years, and light takes time to travel. A signal sent from a civilization 20,000 light-years away would take 20,000 years to reach us. By the time we received it, the civilization that sent it might no longer exist. By the time we sent a reply and it arrived, 40,000 years would have passed. Neither civilization would still be recognizable. This creates what Brian Cox calls the cosmic echo problem. Any signal we receive is an echo of the past. Any signal we send will arrive in the future. Communication across light years is communication across time, and civilizations do not last long enough for such delayed conversations to be meaningful. Imagine sending a letter that takes 20,000 years to deliver. By the time it arrives, the recipient's entire civilization has risen and fallen. Their descendants, if any exist, speak different languages, have different technologies, live in different ways. They might not even recognize the letter as a communication. They might not even remember that their ancestors were expecting one. This is the tyranny of light speed combined with the brevity of civilizations. Even if aliens could detect us, even if they knew exactly where we were, the information would be obsolete before it could be acted upon. They would be detecting the Earth of the past. Their response would arrive in our future. Meaningful communication across these timescales is impossible. Brian Cox finds this one of the most poignant aspects of our cosmic situation. We imagine making contact as a meeting of contemporaries, two civilizations shaking hands across the void. But the void is measured in light years, and light years are also time. There is no present moment in the universe. There is only the past reaching us at the speed of light. The fourth barrier is the problem of scale. This is related to distance but distinct from it. The universe is not just large. It is large in a way that makes comprehensive searching impossible. No matter how advanced a civilization becomes, they cannot search everywhere at once. They must choose where to look. Let me illustrate this with a thought experiment. Imagine an alien civilization 1 million years more advanced than us. They have technology beyond our imagination. They have conquered challenges we cannot even formulate. They decide to search the galaxy systematically for signs of intelligence. The galaxy contains 400 billion stars. If they could examine one star per second, which is impossibly fast, examining all stars would take about 12,000 years. But examining a star is not enough. They need to examine each star's planetary system. They need to look at multiple wavelengths. They need to observe for extended periods to detect patterns that indicate intelligence. A realistic survey of one star system might take hours, days, or weeks. At one star system, per Dalton Y., surveying the entire galaxy would take over 1 billion years. A billion years of continuous searching, even for a civilization that lasts millions of years. This is an impossible task. The galaxy is simply too large to search comprehensively, and the problem compounds further when you consider what they are searching for. They do not know what human technology looks like. They do not know what frequencies we use. They do not know what patterns our signals create. They are searching for something they cannot describe, in a place they cannot narrow down, during a time window they cannot predict. This is not like searching for a known object with known characteristics. This is like searching for something that might not exist, might look like anything, might be anywhere, might only be detectable for brief moments. The search space is effectively infinite, and the target is effectively invisible. Brian Cox has emphasized this point repeatedly. We often imagine advanced civilizations as essentially omniscient. They know everything. They see everything. They have mapped the entire galaxy. But the physics of information makes this impossible. There is too much space. There are too many stars. No matter how advanced you become, you cannot look everywhere at once. And here is the deeper problem. Even if aliens were searching, they would have no reason to prioritize our region of space. The Sun is an unremarkable star in an unremarkable part of an unremarkable spiral arm. There is nothing special about our location that would draw attention to it. We like to think we are special. We like to think Earth is unique. But from a cosmic perspective, we are statistically insignificant. One rocky planet among trillions. One sun, like star among billions. One spiral arm among many. Why would anyone look here? The fifth barrier is the problem of recognition. This is the most subtle barrier, but it may be the most insurmountable. For aliens to detect us, they would need to recognize our signals as artificial. They would need to distinguish our transmissions from natural phenomena. And this is far harder than it sounds. When pulsars were first discovered in 1967, astronomers briefly wondered if they might be artificial signals. The pulses were so regular, so precise, that they seemed designed. The researchers nicknamed the source LGM-1 for little green men, but the signals were natural, rapidly rotating neutron stars producing regular radio beams as they spin. The universe is full of phenomena that can mimic artificial signals: pulsars, quasars, magnetars, masers, regular, patterned, seemingly intentional emissions that are entirely natural. An alien civilization examining our signals would need to distinguish them from this cosmic noise, and our signals are not obviously artificial. Consider what a television signal actually looks like when stripped of its meaning. It is a carrier wave modulated in complex patterns. The patterns encode information, but only if you know the encoding scheme. To anyone who does not, it appears as structured noise, regular in some ways, variable in others, but not obviously a message, not obviously intentional. We have trouble distinguishing artificial signals from natural ones, even on Earth. Radio interference from electrical equipment can mimic astronomical sources. Reflections from satellites can create false signals. The universe provides countless ways to create patterns that look intentional but are not. Human communications are encoded. They carry information in complex patterns designed for our receivers. To anyone else, they would appear as structured noise, different from random noise perhaps, but not obviously intelligent. The signature of intelligence is not as clear as we imagine. Brian Cox has pointed out that we have trouble recognizing intelligence even on our own planet. For centuries, we did not recognize whale song as communication. We did not understand that corvids use tools. We did not grasp the complexity of bee navigation. And these are creatures that evolved on our own world, subject to the same conditions we were. Alien intelligence might be so different from ours that we would not recognize it as intelligence at all. Their communications might use principles we have not discovered. Their signals might operate in ways we cannot detect. The universe might be full of intelligent chatter that we are completely deaf to. Let me bring all of this together. 5 barriers stand between us and any alien civilization that might be searching. The weakness of our signals ensures they cannot be detected at interstellar distances. The vastness of space makes knowing where to look impossible. The brevity of civilizations makes synchronization improbable. The scale of the search makes comprehensive surveys unachievable. And the ambiguity of artificial signals makes recognition uncertain. Each of these barriers is independent. Each would need to be overcome for detection to occur. The probability of overcoming all 5 simultaneously is essentially zero. We are not just difficult to find, we are impossible to find. The universe has constructed multiple layers of invisibility around us. Brian Cox does not say this lightly. He finds it one of the most profound realizations of modern cosmology. For all our ambition, for all our technology, for all our dreams of contact with other minds, we are alone in the only way that matters. Not alone in the universe, but alone in our detectability. Hidden by physics, concealed by scale, invisible by design. If design is even the right word, you might be thinking about objections. What about more advanced technology? What about methods we have not imagined? What about civilizations with capabilities beyond our comprehension? Let me address these carefully because they are the natural responses to uncomfortable truths. The most common objection is the appeal to unknown technology. Perhaps aliens have detection methods we cannot imagine. Perhaps they have overcome the inverse square law through some physics we have not discovered. Perhaps they can search the entire galaxy simultaneously through means beyond our comprehension. This objection has an emotional appeal, but no logical foundation. Technology cannot override physics. Technology works within the laws of nature, not against them. An alien civilization might have better telescopes than us. They might have more sensitive receivers, but they still operate in the same universe we do. They still face the same fundamental constraints. First, technology cannot overcome physics. The inverse square law is not a technological limitation. It is a mathematical consequence of living in 3-dimensional space. No amount of advancement will change how energy disperses across distance. No matter how advanced a civilization becomes, their signals will still fade with the square of the distance. Could they build more powerful transmitters? Yes, but to send a signal detectable across the galaxy, you would need power comparable to the output of stars. This is not impossible in principle, but it is extraordinarily unlikely, and even if such power were available, it would need to be directed at specific targets. Omnidirectional broadcasts at stellar power levels would be prohibitively expensive. Second, the searching problem is fundamental. The universe contains a finite amount of matter and energy. Searching requires both. No matter how advanced a civilization becomes, they cannot create infinite resources. They must choose where to allocate their searching efforts. And the galaxy is too large for comprehensive searching to be possible. Brian Cox has thought carefully about this. We imagine super civilizations as essentially godlike, omniscient, omnipresent. But the laws of physics constrain everyone equally. A civilization a billion years more advanced than us would still face the same fundamental limits. They could not violate thermodynamics. They could not search faster than light allows. They could not be everywhere at once. Third, the synchronization problem is mathematical. Civilizations exist for finite periods. The probability of overlap depends on how long civilizations last and how many exist at any given time. Even optimistic estimates suggest that simultaneous civilizations would be separated by enormous distances, making mutual detection essentially impossible. Could civilizations last for billions of years, perhaps? But we have no evidence of this. Every system we have ever observed eventually fails. Stars burn out. Planets become uninhabitable. Complex systems degrade. Assuming civilizations are immortal is not justified by anything we know. Fourth, the recognition problem may be unsolvable. Intelligence is not a single thing. It is a spectrum of capabilities that evolve differently in different contexts. Alien intelligence would have evolved under different pressures, with different sensory systems, with different communication needs. The probability that their signals would be recognizable to us, or ours to them, is unknown but likely low. Brian Cox has reflected on this extensively. We search for signals that look intelligent to us. But intelligence is not universal. It is contextual. What seems obviously artificial to one species might seem natural to another. The universe might be full of signals that we simply cannot recognize as communications. Let me introduce another concept that deepens this analysis: the cosmic horizon. The universe is not infinite. It is finite and expanding. There is a limit to how far we can see, and this limit affects what aliens could detect about us. Light from Earth has been traveling outward for about 4 billion years, since life first appeared. But the universe is expanding. The space between galaxies is growing. Much of the universe is now so far away that light from Earth will never reach it. The expansion carries it away faster than light can travel toward it. This means there is a maximum volume of space that could ever receive signals from Earth. And that volume, while enormous by human standards, is a tiny fraction of the total universe. Most of the universe is forever beyond our reach. Most of the universe will never know we existed. Let me put some numbers on this. The observable universe contains roughly 2 trillion galaxies. Each galaxy contains hundreds of billions of stars. The total number of stars is approximately 10 to the 24th power, 10 with 24 zeros after it. But the volume we could ever reach with signals is vastly smaller. Light from Earth has been traveling for about 4 billion years since life emerged. But most of the universe is expanding away from us faster than light can travel toward it. The reachable volume shrinks daily relative to the total. In cosmic terms, we are shouting into a room that is expanding faster than sound can travel. Most of the room will never hear us. Most of the room is already beyond the reach of our voice, and the room gets bigger every moment while our voice stays the same. Brian Cox finds this both humbling and clarifying. We sometimes imagine the universe as a stage on which we might make ourselves known. But the stage has edges. The audience is limited. Most of the cosmos is permanently beyond our influence. We are not broadcasting to the universe. We are broadcasting to a small neighborhood that shrinks relative to the whole as expansion continues. What does all of this mean for the search for extraterrestrial intelligence? It means that SETI, as traditionally conceived, is probably futile. Not because aliens do not exist, but because the physics of detection makes finding them essentially impossible. We will not receive signals from distant civilizations. They will not receive signals from us. The gulfs are too vast. The signals are too weak. The windows are too narrow. This is not a popular conclusion. We want to believe that contact is possible. We want to believe that the universe is a community waiting to be joined. The idea of cosmic loneliness is uncomfortable, but physics does not care about our comfort. Physics describes what is, not what we wish. Brian Cox has spoken about this with characteristic honesty. He does not find the conclusion depressing. He finds it clarifying. If we cannot be found, if no one is coming, then the responsibility for our future rests entirely on us. We cannot wait for alien wisdom. We cannot hope for cosmic rescue. We must become our own salvation. Let me offer a different perspective on our invisibility. Perhaps it is not a curse. Perhaps it is a protection. If we cannot be found, we cannot be harmed by whatever might be out there. The same barriers that prevent contact also prevent conflict. We are shielded by our insignificance. There is a school of thought called the dark forest theory. It suggests that the universe is dangerous, that civilizations hide because revealing themselves invites destruction, that the silence of the cosmos is not empty but cautious. If this is true, our invisibility is a blessing. Our weakness is our armor. Brian Cox does not fully endorse this theory, but he acknowledges its logic. We have no way of knowing what attitudes alien civilizations might hold. We have no way of predicting their responses to detection. In the absence of knowledge, caution seems prudent, and the universe has made us cautious by default, by making us undetectable. But let me return to the central point. The universe has not just made contact difficult. It has made contact impossible. The barriers we have examined are not challenges to be overcome. They are features of reality. They are built into the structure of physics itself. The speed of light ensures that signals fade before they can be detected. The size of the galaxy ensures that searching everywhere is impossible. The brevity of civilizations ensures that windows of detectability rarely overlap. The ambiguity of signals ensures that recognition is uncertain. These are not accidents. These are the rules by which the universe operates. Brian Cox has said that the universe seems designed, if that word can be used, to prevent contact between civilizations. Not maliciously, not intentionally, but effectively. The same physics that allows stars to form and planets to exist and life to emerge also ensures that the products of that emergence remain isolated. We are children of the cosmos, but we are also prisoners of it. What should we do with this knowledge? How should we respond to our cosmic invisibility? I think the answer is to focus on what we can do, rather than mourning what we cannot. We cannot be found by aliens, but we can find ourselves. We can understand our world. We can build our civilization. We can create meaning in a universe that provides none. The search for extraterrestrial intelligence has taught us something valuable, not about aliens, but about ourselves. We are rare. We are precious. We are alone in our detectability, if not in our existence. That makes us more valuable, not less. It makes our civilization more important, not less. Brian Cox has made this point eloquently. The universe is under no obligation to make sense to us. It is under no obligation to provide us with company. It is under no obligation to make us findable. And yet, here we are, conscious, curious, capable of wondering about our place in the cosmos. That wondering is not diminished by our invisibility. If anything, it is enhanced. We wonder because we must. We search because it is in our nature. We hope for contact even knowing it will not come. That hope is not foolish. That hope is human. Let me offer a final reflection. We began by discussing why no alien civilization will ever find us. We have walked through the physics of detection, the mathematics of probability, the constraints of time and space. We have seen that the barriers are fundamental, not technological. We have understood that invisibility is our permanent condition, but invisibility is not the same as insignificance. We may be hidden from the cosmos, but we are not hidden from ourselves. We may be undetectable to alien civilizations, but we are present to each other. The connections we seek among the stars are already here, on Earth, in our relationships, in our communities, in our shared humanity. Brian Cox has spent his career trying to help people understand the universe. He has traveled the world, stood on mountaintops, gazed through telescopes, and shared what he has learned. He knows that the cosmos is vast and indifferent. He knows that we are small and isolated, and he knows that none of this diminishes the wonder of being here at all. The universe is not listening for us. The cosmos is not watching. We are invisible in the deepest possible sense, but we are not invisible to each other. We are not unknown to ourselves. And in the end, that is what matters. Not whether aliens find us, but whether we find each other. Look at the stars tonight. See their ancient light traveling across the void. Know that no one out there can see the light from your world. Know that your signals have faded into noise. Know that you are hidden, invisible, undetectable, and then look at the person next to you. See them clearly, hear their voice, feel their presence. That is where the universe lives for you. Not in the unreachable distance, but in the present moment. Not among the stars that cannot see you, but among the people who can. The aliens will never find us, but we have found each other, and that is enough. Brian Cox would say that this is the mature response to our situation, not despair at our invisibility, not fantasy about contact. That cannot occur, but gratitude for what we have, wonder at what we are, determination to make the most of our brief hidden existence. We are alone in our detectability. We are not alone in our existence. Somewhere out there, other civilizations may be having the same realization. They too are invisible. They too are hidden. They too are reaching out into a void that cannot hear them. We are all prisoners of the same physics. We are all hidden by the same barriers. And perhaps in that shared condition, there is a kind of connection after all. Not a connection of signals and messages, but a connection of circumstance. We are all in this together, even if we will never know it. The verdict is rendered. No alien civilization will ever find us. The physics forbids it. The mathematics confirms it. The universe has ensured our permanent invisibility. But within that invisibility, within that isolation, there is room for everything that matters. Room for love, room for discovery, room for meaning, room for wonder. We are not found. We do not need to be found. We are here. We are conscious. We are wondering. And that is miracle enough. Look at the stars one last time. Beautiful and forever unreachable. Now look at your own hands. Real and present and yours. That is where your universe lives. That is where your meaning waits. That is home. The case is closed. We are invisible. We are hidden. We are alone in every way that contact requires, and we are enough. More than enough. We are the universe knowing itself, even if no one else will ever know we are here. There is a strange comfort in this conclusion. For centuries, humanity has looked to the skies with a mixture of hope and fear. Hope that we might not be alone. Fear of what we might find. The resolution of both is the same. We are alone in every practical sense. No rescue is coming. No invasion threatens. No cosmic community awaits our membership. This clarity is liberating. We do not need to wait for answers from the stars. We do not need to fear contact we cannot make. We are free to focus on ourselves, on our planet, on our future. The questions we must answer are questions we must answer ourselves. Brian Cox has said that this is ultimately a message of responsibility. If no one is watching, we must watch ourselves. If no one is coming, we must save ourselves. If no one will judge our civilization, we must judge it ourselves. The burden of meaning falls entirely on us. And perhaps that burden is not a curse but a gift. Perhaps the absence of cosmic neighbors gives us the space to become who we are meant to be. Perhaps our isolation is the condition for our growth. Perhaps we needed to be alone to discover what we are capable of. The universe does not owe us company. It does not owe us meaning. It does not owe us answers. But it has given us consciousness. It has given us curiosity. It has given us each other. And it has given us this beautiful, fragile planet to call home. We are invisible to the cosmos, but we are visible to ourselves. We are hidden from alien eyes, but we see each other clearly. We are alone among the stars, but we are together on this world.